So hello everyone. In continuation with the previous video, we are on chapter 3 of the book Introductory Econometrics, and the chapter name is Multiple Regression Analysis Estimation. And let's start with the question number 6. In this question number 6, you can see the dataset wage 2 is being used. Therefore call this data through data command and use this package Woolrich, press Ctrl plus enter and attach this dataset. Now, what is the endpoint of this question? It asks to verify this relationship beta 1 tilde equals to beta 1 cap plus beta 2 cap into delta tilde 1. Okay, so what is the difference between beta 1 tilde and beta 1 cap? Beta 1 tilde is being used to differentiate from beta 1 cap because beta 1 tilde means that this coefficient has come from a simple regression model. It has come from an underspecified model, and beta 1 cap represents that this coefficient has come from the multiple regression model or a better specified model. Okay, now let's see what it says. The first part of the question, it says run a simple regression of IQ on education to obtain the slope coefficient, say delta tilde 1. Okay, so let's create a model by the name of IQ model. Use this assignment operator, then IQ tilde education. Press Ctrl plus enter. Now look at the second part of the question. Run the simple regression of log wage on education and obtain the slope coefficient beta 1 tilde. Now create a model by the name of simple wage model. Use assignment operator, then LM, and in the bracket use log wage tilde education. Press Ctrl plus enter. And then the third part says run the multiple regression of log wage on education and IQ and obtain the slope coefficients beta 1 cap and beta 2 cap. Create a new model by the name of multiple wage model and then use assignment operator and log wage, use this log wage tilde education plus IQ. Press Ctrl plus enter. And then what we have to verify? We have to verify that beta 1 tilde, that is the coefficient from second part, is equal to beta 1 cap plus beta 2 cap into delta tilde 1. Okay, now what we will have to do, let's summarize this, all the models. So in this we can see that the coefficient on education is delta tilde, that is it is 3.5338. Okay, so this is our delta 1, delta tilde 1. Now summarize this simple wage model to get the beta 1 tilde. Now the coefficient on education is 0.05. This is our beta 1 tilde. Now let's summarize this multiple wage model, and here we will get our beta 1 cap and beta 2 cap. So the coefficient on education is beta 1 cap 0.039 and the coefficient on IQ is our beta 2 cap 0.005. Okay, now since we have to verify this relationship, let's see what is beta 1 cap is 0.039. Let's take up to 5 decimal places, 1 2. Okay, now plus what is our beta 2 cap? Beta 2 cap is 0.00586. And it is being multiplied by delta tilde 1. So delta tilde 1 we will get it from the first part, which is summary IQ model, simple IQ model. So here it is 3.5338. Press Ctrl plus enter. Here it is, the result is 0.0598. And now let's look at beta 1 tilde, that is summary simple wage model. Here it is, the coefficient of education is our beta 1 tilde. So here it is 0.0598 and here it is 0.0598. Okay, so we have verified this relationship, and any difference, any small difference is due to rounding error. Okay, so now we are done with this question. Let's detach this dataset. Press Ctrl plus enter. Now let's start with the question number 7. It utilizes the data set MEAP93 Let's call this data set through data command and use this package voltage. Press Ctrl plus Enter, attach this data set. Now here we are. What is the first part of the question? It says to estimate the model math 10 on the basis of log expand and lunch program. Okay, so let's create a model by the name of math underscore model, and math 10 is being estimated by log expand here is expenditure, and math 10 is pass rate in mathematics subject, and lunch program is the lunch program of schools, is the number of schools running this lunch program. Okay, so press Ctrl plus Enter and then summarize this model. And it also says to report the results in the usual form, including the sample size. So what is the sample size? Use this command nobs, it means number of observations, and in the bracket type the model's name, math model. So the number of observations is 408 and the intercept is minus 20.36, minus 20.36, and the coefficient on log expand is 6.22. It's almost equivalent to 6.23, and the coefficient on lunch program is minus 0.304. Okay, so are the signs of the slope coefficients what you expected? The signs of the estimated slopes imply that more spending, since the coefficient on log expand is positive, so it means that more spending increases the pass rate holding lunch program fixed, and a higher poverty rate which is being proxied by lunch program decreases the pass rate holding spending fixed. So these are what we expect obviously. Now what is the second part? What do you make of the intercept you estimated in part first? In particular, does it make sense to set the two explanatory variables to 0? Okay, so what is the intercept? It is minus 20.36. It means that if these other two explanatory variables are set to 0, then the pass rate will be in the negative, which is impossible. Pass rate can be at most equivalent to 0, it cannot be negative. So it does not make sense, first of all, to set the two explanatory variables to 0. And setting lunch program equals to 0 still makes sense, as there are schools with low poverty rates. Okay, but setting log expand equal to 0 does not make sense, because it is the same as setting expand equals to 1, and spending is being measured in dollars per student, and log 1 equals to 0. Therefore setting log expand equals to 0 does not make sense, and but still we can make lunch program equals to 0. Okay, so we are done with this part. Now let's go to the third part of this question. Now run the simple regression of math tan or log expand and compare the slope coefficient with the estimate obtained in part first. Okay, now let's create a new model by the name of simple math model and use this assignment operator and then lm math tan tilde log expand. Let's summarize this model. Here the now look at this other part of the third part. It says that is the estimated spending effect now larger or smaller than in first part. In the first part, where we had two variables in the equation, the coefficient on log expand was 6.23. Okay, the coefficient on log expand was 6.23 when lunch program was also included as an explanatory variable, and here in this equation where only log expand is being included to determine the math pass rate, the coefficient on log expand is 11.16. It is almost the double of the coefficient in part first. Okay, so the estimated spending effect is larger than it was in part first. Okay, now look at this fourth part. It says to find the correlation between log expand, which is equal to L expand. There is a column in this data set which is named as L expand, and it is log expand, and so the question says to find the correlation between L expand and the lunch program. Does that sign make sense to you? Now let's calculate the correlation by typing COR core, and in the bracket type L expand and lunch program. The order does not matter. So the correlation is minus 0.19, which means that on average high schools with poorer students spend less per student. So this makes sense obviously, especially in 1993 in Michigan, where school funding was essentially determined by local property tax collection. And now the fifth part of this question says use part fourth to explain your findings in part third. Okay, so it basically says why when only log expand was included in the equation to calculate simple math model, the coefficient of log expand was much larger, and then when two variables were included in the equation, the coefficient of log expand was much smaller. So why this happened? So there is an equation uh, in the book 3.23. Okay, so we can use that equation to answer this question. Now since the correlation between these two variables is less than 0, that is it is negative, the simple regression estimate, that is log expand in this equation simple math model, is larger than the multiple regression estimate in the original model. So intuitively, failing to account for the poverty rate leads to an overestimate of the effect of spending. Okay, so we are done with this question. If you have any queries, if you have any problems regarding the solution of these questions, you can always type in the comment box. I will answer these questions in detail. Okay, and I will also give you the page number and equation number to give explanation for these solutions. Okay, so now we are done with this data set. Let's detach this data set. Now let's go to the question number 8. The question number 8 utilizes the dataset discrim. So call this dataset by using data command, and in the code discrim package Woolrich, press Ctrl plus enter, attach this dataset. Now what it says, there are zip code level data on prices for various items with characteristics of the okay. The idea is to see whether fast food restaurants charge higher prices in areas with a larger concentration of blacks. Now the first part of the question says find the average values of proportion of black and income in the sample along with the standard deviations. What are the units of measurement of proportion of black and income? So first calculate the mean of the this data column named proportion black, and while calculating mean there are some NA values in the column. So you can use this parameter. You can set this parameter na.rm equals to t. You can either type the whole word true or simple the alphabet T is enough. Press Ctrl plus enter, and then we have to also calculate the mean of income. Okay, so what we get here, the average proportion of black is 0.113. Okay, with standard deviation we also have to calculate standard deviation. 1 minute. Here also we have to use this parameter na.rm equals to true, and here also we have to calculate the standard deviation of mean, standard deviation of income, and na.rm equals to true. It is the same thing. You can either use this whole word true, true, or simply write just the alphabet T in capital. Okay, so here are we. The average of proportion black is 0.113 with standard deviation of 0.18, and the average of income is $47,053 with the standard deviation of 13.179. And what are the units of measurement? It is evident that proportion black is a proportion and that income is being measured in dollars. Okay, so now what is the second part of this question? Consider a model to explain the price of soda in terms of the proportion of the population that is black and median income. Estimate this model by OLS and report the results in equation form. Now let's create a model by the name of food underscore model. Use this assignment operator, and then P soda is being estimated by proportion of black and income. Press Ctrl plus enter and summarize this model. Says to report the results in equation form including sample size and r squared. What was the sample size? Use this command number of observations nobs, and then in the bracket type food model. The sample size is 401 and the R squared value is 0.064. Okay, so here are we. Interpret the coefficient. Interpret the coefficient on proportion black, and do you think it is economically large? So the coefficient on proportion of black is 0.114. It is almost equivalent to 0.115. So it says that if proportion black increases by 10 percentage points, the price of soda is estimated to increase by $0.0115 or about 1.2 cents. While so it is not large, okay. So this does not seem large, but there are communities with no black population and others that are almost all black, in which case the difference in pea soda is estimated to be about 11.5 cents. So it is not economically large in itself, but there are some communities where there is no population, no black population, and others that are almost black. So in those extreme cases, the difference in pea soda is estimated to be almost 11.5 cents. Now compare the estimate from part second with a simple regression estimate from P soda on proportion of black. So it says, is the discrimination effect larger or smaller when you control for income? Now let's see the simple food model by create a model by the name of simple food underscore model, and then estimate the price of soda on the basis only of proportion of black without controlling for income. Press Ctrl plus enter and then summarize this model. In this case, the coefficient on proportion of black is 0.065. Okay, so the simple regression estimate is actually lower. So this is because proportion of black and income are negatively correlated. Okay, the correlation between those two values is negative, and income has a positive coefficient in the multiple regression. So when we do not control for income, the coefficient on proportion of black is smaller than before. Now let's look at the fourth part of this question. A model with a constant price elasticity with respect to income may be more accurate. Report estimates of the model. So let's create a new model by the name of log food model. Okay, log food underscore model, and then use this assignment operator, and then the p soda price of soda should be in logarithm form, and it is being estimated by log income. Okay, so press Ctrl plus enter, and then let's summarize this model. In this case, now what is the other part of this question? If proportion black increases by 0.20, 20 percentage points, what is the estimated percentage change in p soda, price of soda? So what is the coefficient on proportion of black? It is 0.0121. It is almost equivalent to 0.122. So if proportion of black, let's see what happens. If proportion of black is increased by 0.20 percentage points, then what will be the effect? Press Ctrl plus enter. 0.20 into 0.122. 0.122 is the coefficient on proportion of black. So the answer will be 0.0244 or 2.44%. So if proportion of black increases by 20 percentage points, log p soda is estimated to increase by 2.44%. Now the fifth part of this question says, now add the variable PRP POV to the regression in part 4. What happens to coefficient on proportion of black? Let's create a model by the name of new log food underscore model, and then add this variable proportion POV. Now estimate this model by pressing Ctrl plus enter, and then summarize this model. By adding this variable PRP POV, the coefficient on proportion of black falls to about 0.073. Okay. Now what it says? It says to calculate the correlation between log income and PRPPOV. Is it roughly what you expected? Let's see. Okay, since the two data columns contain some NA values, the simple core function will not give you the correlation value. We will have to use a different function named core.test and then include these two variable names in the bracket and press Ctrl plus enter. So this is our value, correlation value, minus 0.083 minus 0.838. It is almost equivalent to minus 0.84, and it makes sense because poverty rates are determined by income. Okay, so yeah, this is the value which we might have expected. Now let's look at the seventh part of this question. Evaluate the following statement. Because log income and PRPV so highly correlated, they have no business being in the same regression. Okay, we can see that these values are highly correlated, but we are using them simply as controls to determine if there is price discrimination against blacks. In order to isolate the pure discrimination effect, we need to control for as many measures of income we can, including both variables makes sense. Okay, so this was the answer. If you need further explanation, then do type in the comment box. So we are done with this data set. We are done with this question. So let's detach this data set. Now let's come to the question number 9. The question number 9 uses the dataset charity from the package Woolrich. Press data underscore charity and then package equals to Woolrich. Attach this dataset. It says to estimate the equation gift on the basis of males per year and the average pass level of gift, and this is the other variable. This is one more variable. So now let's create a new model by the name of gift underscore model, and then use assignment operator and then type LM linear model and gift tilde males year gift last and prop ESP. Press Ctrl plus enter and summarize this model, and then also calculate the number of observations of this model. So the number of observations in this sample in this data set is 4268, and the R-squared value is 0.083. The intercept is minus 4.55, and the coefficient on males per year is 2.17. The coefficient on gift last is 0.0059, and the coefficient on proper ESP is 15.36. How does the R squared compare? Now look at the other part of the question. How does the R squared compare with that from the simple regression that omits gift last and proper ESP? So let's create a new model by the name of simple gift model, and in this model gift is being estimated only by males per year. So type just gift tilde males per year, press Ctrl plus enter and summarize this model. This simple regression, the R squared value is only 0.013, and in the previous multiple regression the R squared value was 0.083. So the variables gift last and proper ESP help to explain significantly more variation in gifts in the sample. Okay, although still just over 8%, but still they help to explain more than before. Now let's look at the second part of the question. Interpret the coefficient on males per year. Is it bigger or smaller than the corresponding simple regression coefficient? So in this case the coefficient on males per year is 2.64, and in the previous model the coefficient on males per year was 2.166. So holding gift last and proper ESP fixed one more mailing per year is estimated to increase gifts by 2.17 guilders in this multiple regression case, whereas the simple regression estimate is about 2.65. Okay, so the multiple regression estimate is somewhat smaller. The simple regression coefficient is somewhat bigger than the multiple regression coefficient. Now the third part says interpret the coefficient on proper ESP. Be careful to notice the units of measurement of proper ESP. Okay, so because proper ESP is a proportion, it makes little sense to increase it by 1. Such an increase can happen only if proper ESP goes from 0 to 1. Instead, we should consider a 0.1 increase in proper ESP or 10 percentage point increase. So uh, then gift is estimated to be 1.54 guilders higher. Suppose what is the coefficient on proper ESP? 15.35. So in this case, if it increases only by 10 percentage points, that is 0.1, then it will increase the cost of the gift by 1.54 guilders. Now add the variable average gift to the equation. What happens to the estimated effect of males per year? Let's create a new model by the name of new gift underscore model, and then add one more variable by the name of average gift in this model, and press Ctrl plus enter, and then summarize this model. Now we have to look at the coefficient of males per year. It is 1.20. So after controlling for the average pass gift level, the effect of mailings becomes even smaller. Okay, and it is almost 1.20 guilders, or it is also, you can say, half of the effect estimated by simple regression. In the simple regression, the estimate was 2.65, and now it is only 1.20, so it is less than half of the estimated coefficient from the simple regression. Now look at this fifth part of the question. In the equation from part 4, what has happened to the coefficient on gift last? What do you think what is happening? After controlling for the average of past gift, we find that the current gift amount is negatively related to the most recent gift. Okay, so after including this average gift from the past, the current gift amount is negatively related to the most recent gift. So a negative relationship makes sense, as people might follow a large donation with a smaller one. Therefore it makes sense. Okay, so we are done with this question. Let's detach this data set. Thanks for watching this video. If you like my videos, then subscribe to this channel, and also you can follow me on different social media platforms. I have mentioned this link in my description box. Thank you.